Alright, boys and girls, as you can tell, you have a substitute today. I'm not feeling well, so I'm at home getting some rest so that I can be with you guys tomorrow. What you're going to do is you're going to watch this video, you're going to take some notes, and then you're going to do some homework. All of this needs to be completed in class. I recommend you do this on a separate sheet of paper so you can turn it in at the end. Again, take notes and homework, separate sheet of paper, turn it in at the end of class. Alright, so we've got Barbie here, right next to a normal human being. You can see how small her head is, how large her chest is, how small her waist is, how long her legs are. And what we're talking about is proportional relationships. If Barbie was the same height as people are, this is what she would look like. Is this proportional? Do people look like that? No. And in math, we can actually represent proportions with an equation. Alright, so what does it mean if an equation is proportional? First, the equation will look like this. Y equals kx. Now, this is a lot like y equals mx plus b. However, the y-intercept, the b, is going to be 0. So there's no y-intercept written in the equation. K is just like the m. It's the slope. And the graph is going to go through the origin. It has to go through the origin, otherwise the intercept would not be 0. Okay, so this is an example of a proportional relationship. No y-intercept. And the slope is 3. And we can see that in the graph because the rise is 3 and the run is 1. So we know that this is a proportional relationship. Let's look at an example. The table shows the number of miles driven for each hour driving. Graph the data. What can you deduce from the pattern about the relationship between the number of hours driving H and the number of miles driven? Alright, we have no negatives, so our graph can simply be in the positive region. X goes on the horizontal axis, which is our number of hours, and Y goes on the vertical axis, which is the number of miles. 50, 100, 150, 200, going up by 50s, and hours, 1, 2, 3, 4. Alright, put our points in there. 150, 2 100, 3 150, 4 200. And obviously, your graph is going to look way better than mine because you have grid paper. Now, what can we deduce? Is this a proportional relationship? Is it going through the origin? Do we have a constant rate of change? Well, then I would say this is a proportional relationship. The relationship between hours and miles is proportional. Alright, write an equation to describe this relationship. Now remember, it's y equals kx. The only thing we have to fill anything in for is the k. And remember, k is slope, which is the rise over the run. And remember, the rise comes from the y and the run comes from the x. So the y's are going up by 50. And the x's are going up by 1. So my slope is 50. So that means my equation is y equals 50x. X being the number of hours, and y being the number of miles. Now we're going to use this equation to predict the number of miles driven in 8 hours. So we're going to do y equals, so the number of miles driven is 400 miles. Alright, let's do another problem. Alright, this time we have a table again, and we need to write an equation to describe the relationship. And the first thing we need to do in order to write an equation is to decide, is it proportional? Will this go through the origin? What would it be? So we've got the rise of 1.5, and that pattern continues. And we've got a run of 1, and that pattern continues. Does it go through the origin? What if I continue the pattern this way? Subtract 1, that would give me 0. Subtract 1.5, that would give me 0. So it does go through the origin, so it is proportional. So again, y equals kx. What's k? The rise over the run. 1.5 over 1, which is 1.5. So my equation is 1.5x. Use the equation from part B to predict the number of miles driven in 8 hours. So we do y equals 1.5 times 8, and that will give us 12 miles. Now, obviously, this is a different problem than the previous one. We're going much slower, so maybe we're walking or riding a bike, whereas in the other problem, we were probably driving a car. All right, let's look at another example. Non-proportional relationships. A non-proportional relationship does not go through the origin, okay? So it becomes a step more difficult. If it's proportional, all we have to find out is k. Non-proportional, we are going to have to find out the y-intercept. Alright, so we're going to write an equation for this graph, and the first thing we need to do is select points from the graph and put them in a table of x's and y's. So we've got 1, 1. We've got 2, 4. We've got 3, 7. We've got 4, 10. And we've got 5, 13. Alright, now we need to look at the slope. We're looking at the differences between the x's and the y's. This is going up 3, and this is going up 1. So let's write an equation as we would for a non-proportional. That would give us y equals 3x, because the rise is 3 and the run is 1, which simplifies to 3. Now, we need to test it. So, if this equation works, when I plug in a 4, I should get a 10. So if I plug in 4 for x, so 3 times 4, I get 12. But I want to get 10. How can I change that equation to make it work? Well, I'm going to have to subtract 2. So my equation is y equals 3x minus 2. Let's test to see if that works. If I plug in a 5, that gives me 3 times 5, which is 15, minus 2, which is 13. It works. So my final answer, my equation, is y equals 3x minus 2. Let's try another one. Write an equation for the relation that is graphed. Alright, is this proportional? Does it go through the origin? so it's non-proportional. So it's going to be a y equals mx plus b. Alright, so let's start by making a table of those points. We've got 0, 1. We've got 1, 3, 2, 5, 3, 7, 4, 9. What's our slope telling us? We're going up by 2 and over 1. So my m, or my k, is 2. So we have y equals 2x. Does that work? Let's test it. If I plug in a 3 for x, I get 6. But I want to get 7. So how do I need to change this equation? I need to add 1. So my final equation is y equals 2x plus 1. And let's check, let's make sure it really works. Plug in a 4. 2 times 4 is 8. Plus 1, 9. So the correct equation is y equals 2x plus 1. Doing great, you guys. So what is the difference between a proportional and a non-proportional graph? A proportional graph is going to go through the origin. Man, I can't get that line to go through the origin. Holy cow. You get it. It goes through the origin. A non-proportional graph does not go through the origin. How about an equation? A proportional equation, since it does not go through the origin, does not have a y-intercept in the equation. It's simply y equals kx. The equation of a non-proportional does have an intercept other than 0. So it has an additional part added on. Alright, make sure you got some notes. You're turning these in so I can see that you actually watched the video during class today. And on that same note piece of paper, I'd like you to do the following 5 problems, 4 through 8. And you are turning this in. Make sure you put your name on it. Needs to be done by the end of class. 5 problems. I know you can do it. Super straightforward. Good luck, and I'll see you guys tomorrow.